a quick update from where I left off previously. So I now have my ROM and RAM working, I believe. At the end of the last video, I was getting some output, but it wasn't looking quite right. And so I just kind of have gotten in here to start debugging and understand what's going on. And really there are three things that I did to get output to look correct. And maybe let me just start out by pulling up my Arduino logger. And I'm going to flip the system on. You will see that I've added some additional things in my logging, like ALE, DEN, and DTR, and I'll explain why here in a moment. But here I am getting to the FFFF0, and again, I'm trying to get this jump back to the top of my code, which there it did it. So I got back to this 80000. I do a CLI, I set up my registers with a bunch of moves, and then eventually I want to write out to RAM, this is 0F0F, and I do that, and I can see a RAM write and the 0F0F. I later read it back from address 1000. So that's all working well, and if I look at my bar graph, I'm seeing when I do an output, I'm seeing that 0F0F. And if I just go back to that code for a second, here is the code I'm running as part of this. I had some previous code in there that helped me to do a different thing in a previous video. I commented these out because I actually don't want that in this specific example. And so that was one of the things I did, because I was moving basically my data segment to be the same as my code segment, which meant ROM, and you obviously can't write to ROM. So I was running into an issue with that. So I fixed that for now, just took this out. And then besides that, I had two other problems. One problem was that in my schematic and the way I hooked it up, these address latches have an ALE signal controlling them, and I have then my transceivers, and there's a DEN and a DTR. And on my previous schematic, I was pulling DEN straight from the bus controller. But as I was looking at it, something wasn't right, so I went in and added that to my logging so I could track DEN and DTR, so I knew if I was sending data out or in through the transceivers, and if it was enabled, if the transceivers were enabled. And I wasn't getting what I was expecting to see there. And as I read back on it, this bus controller, DEN is an active high. So when that's active, I want this transceiver to output. Well, that means I need to invert it, so I need an inverted DEN. So to address that, what I did is I just quickly went over to my PSOC, because my DEN is coming out here. I ran it into the PSOC, inverted it, and then brought it out. And so that was an easy fix. I didn't add an inverter to an inverter IC. I just simply used the PSOC to do that. So here's my DEN in, my inverted DEN coming out. And if I want to look at that in my PSOC, it's as simple as this, DEN, invert, DEN B. And then I set up pins for DEN and DEN B, and I connected to that. So that was easy. And then at that point, things were looking better, but still not quite right. I was reading basically 2 bytes further ahead than I thought I should be. So at a certain address, I was getting data for 2 bytes later. Well, that to me told me I probably had a wiring issue. So I went and took a look at my ROM, and yep, when I connected my ROM to the address lines, I had a set of them that were off by 1 pin. I had missed a pin basically, and everything after that was off by 1 pin. So I just picked them up, slid them over, dropped them back in. And so with those 3 changes, inverting my DEN signal for my transceivers, correcting which wires were connecting down here to my ROM for the address lines, and then making a slight adjustment to that assembly code, I am now getting pretty good behavior here. And this logic decoding for these columns here, where it's trying to just guess, if this data was an instruction, what instruction would it be? I'll clean that up later so it doesn't show false information, because right now, like PVAM is it really doing that? Or when I have ADC and ADD on the same, what is it really doing? And I think I can interpret that looking at some of these other signals. So I'll see if I can make that more precise as I move forward. But it's at least a quick way, and it looks like it is so far working. I'm seeing it go through the loops. And so here it just jumped back to 8000F. And if I go look at the listing file for this, and I look at, well, what address when it got assembled is at that 800F, that is my move right within loop, because I'm saying at the end of this, jump back to loop. So it's just going to loop and loop and loop. So that 80000F is what it's looping back to. And in this, I'm just simply moving an address, basically a pointer, into my B register. I'm moving a value into that spot in memory, and then I'm pulling that value back out of memory into the A register, and then I'm going to go ahead and send that out as if it was I/O. Nothing's listening to that, but it lets me see it on my data. And so when I see the 0F, 0F, which should be 4 off, 4 on, 4 off, 4 on, and that is working through and looping just fine. So for my stack to be working, the RAM has to be working. For me to see that value coming out of my AX, the RAM also has to be working, and clearly ROM is working if it's processing all this code. So I'm pretty happy. I think I'm starting to get the basics of a running system here. Maybe in an upcoming video then I can start to get into trying to get this LCD working through one of these PPIs. And prior to that, I've got a whole bunch of wiring cleanup. So I know that this is somewhat working. I'm going to call it good for now. And that gives me enough confidence to go ahead and get rid of these temporary wires and route actual wires that are going to get pinned down and cleaned up. So that's where I'm at, and more to come.